Have you ever wondered how devices talk to each other online? It's a fascinating process that happens every second of every day, allowing us to stay connected in ways we often take for granted. It's like they have their own secret language. This language is what makes it possible for your smartphone to fetch your emails, for your laptop to stream videos, and for your smart home devices to work in harmony. Well, this language is called Internet Protocol, or IP for short. IP is the backbone of the Internet, a set of rules that ensures seamless communication between devices. Think of it as a set of rules that govern how data travels across the Internet. These rules are meticulously designed to handle the vast amounts of data that flow through the web every second. Just like we have rules for sending mail, IP ensures that data reaches its intended destination. Imagine sending a letter without an address. It would never reach the recipient. Similarly, IP makes sure that data packets are correctly addressed and delivered. Without IP, the Internet as we know it wouldn't exist. It forms the very infrastructure that supports global connectivity, enabling billions of devices to communicate with each other. It's the foundation that allows our computers, smartphones, and even smart refrigerators to connect and communicate. Every device, from the smallest sensor to the largest server, relies on IP to function. IP takes care of addressing, which means giving each device a unique identifier. This unique address is crucial for distinguishing one device from another in the vast sea of the Internet. It also handles routing, ensuring that data takes the most efficient path to its destination. Think of it as a GPS for your data, guiding it through the most optimal routes to avoid congestion and delays. So the next time you're browsing the web, streaming your favorite show or video chatting with friends, remember that it's all thanks to the magic of IP. This invisible protocol works tirelessly behind the scenes to make our digital experiences smooth and enjoyable. It's the invisible force that enables all the amazing things we do online. From social media interactions to online banking, IP is the unsung hero of the digital age. In the next section, we'll dive deeper into IP addresses and understand how they work. Stay tuned. We'll explore how these unique identifiers are assigned and managed, and why they are so essential for the Internet's functionality. Just like every house has a unique address, every device on the Internet has a unique identifier called an IP address. This address is a numerical label that tells us two things: the device's location on the network and its identity. It's how other devices know where to send data. Imagine sending a postcard without an address. It would never reach its destination. Similarly, without an IP address, your device wouldn't be able to communicate with other devices on the Internet. There are two main types of IP addresses, IPv4 and IPv6. We'll explore the differences between these two in the next section. Stay tuned to learn more about the evolution of IP addresses. As the Internet grew, we needed more IP addresses to accommodate all the new devices coming online. Every new smartphone, tablet, laptop, and even smart home device required a unique address to communicate over the Internet. This rapid expansion led to a significant challenge. This is where IPv6 comes in. IPv6, or Internet Protocol version 6, was developed to solve the limitations of the previous version, IPv4. It's like upgrading from a small town's phone numbering system to a global one. Imagine a small town where phone numbers are limited to a few digits. As the town grows into a bustling city, the phone system needs to expand to accommodate more people. IPv4, the older version, uses 32 bits, which limits us to about 4.3 billion unique addresses. Initially, this seemed like an enormous number, more than enough for the early days of the Internet. Sounds like a lot, right? But with the explosion of Internet-connected devices, from computers to smartphones to smart refrigerators, we quickly realized that 4.3 billion addresses wouldn't be sufficient. Well, with billions of devices already connected, we were running out of addresses. The Internet was growing at an unprecedented rate, and the need for more addresses became critical. IPv6, on the other hand, uses a whopping 128 bits, providing a nearly limitless number of addresses. This means we can support an almost infinite number of devices, ensuring that every new gadget can connect to the Internet without any issues. This transition to IPv6 ensures that we won't run out of addresses anytime soon, allowing for the continued growth of the Internet. It supports the ever-increasing number of devices and innovations that rely on Internet connectivity. In the next section, we'll look at how data actually travels across the internet using packets. These packets are the fundamental units of data transmission, making it possible for information to move efficiently from one point to another. Have you ever wondered how data actually travels across the internet? It's not sent in one big chunk. Instead, it's broken down into smaller pieces called packets. Think of it like sending a message written on postcards instead of a single sheet of paper. Each packet contains a portion of the data, along with the source and destination IP addresses. These packets travel independently across the internet, like individual postcards, and are reassembled at the destination. IP's job is to ensure that these packets are routed correctly and arrive in order. But how do these packets know where to go? That's where routing comes in, and we'll explore that in the next section. Section 5, Navigating the Web, the importance of routing. Routing is like having a GPS for data packets. It's the process of determining the best path for data to travel across the internet. Just like you wouldn't take the longest route to your destination, routing ensures that data packets take the most efficient path. Routers are special devices that act like traffic directors for data packets. They use information from routing tables to determine the next hop for each packet, ensuring that it gets closer to its destination with every hop. Without routing, the internet would be a chaotic mess, with data packets getting lost or taking forever to reach their destination. Section 6, Public versus Private. Different addresses, different purposes. Not all IP addresses are created equal. They serve different roles and have distinct purposes in the world of networking. We have public IP addresses which are visible to the entire internet, allowing devices to communicate across the globe. And then we have private IP addresses which are used within local networks like your home or office, ensuring internal communication. Your public IP address is assigned by your Internet Service Provider, or ISP, and is unique to your internet connection. This address is how websites and other devices on the internet identify you, much like a digital fingerprint. It's like your home address for the internet, directing traffic to and from your location. Your private IP address, on the other hand, is assigned by your router and is only used within your local network. This address allows your devices to communicate with each other without exposing them to the wider internet. This separation of public and private addresses helps to improve security by keeping internal traffic isolated from external threats. Additionally, it helps conserve the limited number of public IP addresses available, ensuring efficient use of resources. By understanding the roles of public and private IP addresses, we can better appreciate the complexity and efficiency of modern networking. Section 7, Dynamic versus Static. Adapting to network needs. IP addresses can also be dynamic or static. Dynamic IP addresses are assigned automatically by your ISP and can change from time to time. This is the most common type of IP address for home users. Static IP addresses, as the name suggests, remain the same. Imagine if your phone number changed every time you turned off your phone. It would be pretty inconvenient. Static IP addresses are useful for businesses or devices that need a permanent address, like web servers or security cameras. The choice between dynamic and static IP addresses depends on your specific needs and how you use the internet. Section 8, Layers of Communication. Understanding the Internet Protocol Suite. The Internet is built on a layered architecture called the Internet Protocol Suite, also known as TCP/IP. Think of it like a cake with different layers, each serving a specific purpose. The link layer is the foundation, responsible for communication between devices on the same network. The internet layer is where IP comes in, handling addressing and routing. The transport layer ensures reliable data delivery and manages the flow of data between devices. And finally, the application layer is the top layer, where applications like web browsers and email clients operate. This layered approach makes the internet more modular and easier to manage. Section 9, IP and security. Safeguarding your data in a connected world. As we rely more and more on the internet, security becomes paramount. IP addresses, while essential for communication, can also be exploited by malicious actors. Hackers can use IP addresses to launch attacks, steal data, or impersonate legitimate websites. Therefore, it's crucial to protect your IP address and take steps to secure your online activity. By using strong passwords, encrypting your data, and being mindful of phishing scams, you can help protect yourself from IP-related security threats. Remember, staying informed and taking proactive measures is key to staying safe online.